September 1870. The air over Boston is thick with the metallic tang of progress, coal smoke, horse manure, and the damp chill of the Charles River. At the Massachusetts Institute of Technology, a fortress of brick and intellectual ambition, the world is being rebuilt molecule by molecule, gear by gear. But this world is exclusively male. Young men in starched collars stride across the campus, their minds filled with equations for bridges and formulas for industrial dyes. They are the designated architects of the future. And then there is Ellen Henrietta Swallow. She doesn't stride, she proceeds with a quiet, unshakable determination that seems to part the sea of dismissive glances. She is not here for a degree. The Institute's charter and its pride would not permit such a thing. She has been admitted under a carefully constructed loophole, a probationary status as a special student in chemistry. Not for a degree, but as a special student, a probationary exception. The faculty, in a decision documented in their own meeting minutes, voted to admit her with the explicit understanding that her admission be not regarded as a precedent for the general admission of females. She was an experiment, a novelty, a potential problem to be managed. They gave her a space in a dusty corner of the chemistry building, a place where her presence wouldn't disrupt the serious work of the men. Little did they know, from that forgotten corner, she was about to launch a revolution that would save more lives than any bridge they could ever design. Within weeks, the novelty wore off, replaced by a grudging respect from the few professors who witnessed her work ethic. Her lab bench was a model of precision. Her notes a testament to a mind that saw patterns others missed. While her male peers focused on the lucrative chemistry of manufacturing, Ellen turned her formidable intellect to a far more fundamental substance, water. Not the pristine theoretical H2O of textbooks, but the murky, contaminated water that flowed from the taps and wells of Massachusetts. This was a time when cities were exploding, but sanitation was an afterthought. Rivers were treated as open sewers, and the link between contaminated water and diseases like cholera and typhoid was still a fiercely debated, often dismissed theory. The prevailing wisdom was the miasma theory, the idea that disease was spread by bad air, a foul-smelling fog of decay. Ellen suspected this was dangerously wrong. She believed the killer wasn't in the air, but hiding in plain sight in the very liquid people drink to survive. This was a time when cities were exploding, but sanitation was an afterthought. Rivers were treated as open sewers, and the link between contaminated water and diseases like cholera and typhoid was still a fiercely debated, often dismissed theory. The prevailing wisdom was the miasma theory, the idea that disease was spread by bad air, a foul-smelling fog of decay. Ellen suspected this was dangerously wrong. She believed the killer wasn't in the air, but hiding in plain sight in the very liquid people drink to survive. Armed with reagents and glassware, she began a painstaking process of analysis. She wasn't just looking at the water, she was interrogating it. She meticulously measured levels of ammonia, nitrates and nitrites, chemical signatures of sewage and organic decay. She tested for chlorides, a telltale sign of contamination from human waste. Each test was a question, and the answers she uncovered were terrifying. Her early reports, compiled with an unassailable level of detail, were initially met with the polite skepticism reserved for enthusiastic amateurs. She was a woman, a special student, dabbling in the unpleasant subject of waste. But the data was relentless. She demonstrated, for instance, that a well's proximity to a cesspool directly correlated with shockingly high levels of nitrates. She created what she called sanitary maps, color-coding water sources across the state based on their level of contamination. These weren't just lists of numbers, they were visual indictments of a catastrophic public health failure. A red dot on her map wasn't an academic data point, it was a potential outbreak, a cluster of future deaths. Her work soon became impossible for the state's authorities to ignore. The Massachusetts State Board of Health, grappling with recurring epidemics, cautiously took notice. They commissioned her, unofficially at first, then with more formal recognition, to expand her analysis. This culminated in the Great Sanitary Survey of Massachusetts, the first of its kind in the nation and arguably the world. Ellen and her team analyzed over 40,000 water samples. This was a monumental undertaking, a fusion of chemistry, geology, and nascent public health science. She developed new, more efficient methods for water analysis, standardizing techniques that had previously been chaotic and unreliable. Her findings, published in state reports, provided the irrefutable scientific evidence needed to overhaul public water systems, to move water intakes upstream from sewer outlets, and to begin the slow, expensive process of building a healthier world. She had given the state a diagnostic tool for its own sickness. She had proven that chemistry could be a guardian of public life. The institution that had admitted her as a conditional anomaly was now the home of the most important public health research in the country. The question, however, remained hanging in the coal-tinged air. Now that her value was proven, would MIT ever truly see her as a scientist, or was she merely a useful tool to be kept separate and contained? The answer to that question came not in the form of a professorship or a seat on the faculty senate, but in a cage gilded with the name of progress. Following her undeniable scientific triumphs in the Great Sanitary Survey, Ellen Swallow Richards was too valuable for MIT to dismiss, yet too disruptive to the established order to fully embrace. The solution was a paradox of institutional engineering. In 1884, with funding she largely secured herself from the Women's Education Association of Boston, MIT established the Women's Laboratory. She was appointed its head. On the surface, it was a victory, a dedicated space for women to be trained in the chemical sciences, led by the university's most brilliant female mind. But this wasn't an elevation, it was a containment. Archival records from MIT, including letters between administrators, revealed the lab's dual purpose. It was a way to accommodate the growing demand for women's education without integrating them into the main, male-dominated laboratories. It was a separate, unequal space. The women's lab was often underfunded, and its students were not initially eligible for the same degrees as the men. It was a scientific ghetto, and Ellen was its warden, instructor, and chief researcher all at once. From within these walls, however, Ellen's work only accelerated. She expanded her focus from water to the entire human environment. She was pioneering a new, holistic discipline she initially called oikology, the science of living, of the interplay between environment, nutrition, and health. This wasn't just about clean water anymore. It was about clean air, safe food, and hygienic living spaces. She conducted groundbreaking studies on food adulteration, exposing the shocking reality of the 19th century food supply. Her students analyzed samples of milk and found it diluted with water and thickened with chalk or even calf's brains. They found cayenne pepper bulked up with brick dust and canned vegetables grained with toxic copper sulfate to make them look fresh. Her laboratory became a consumer protection agency in miniature, publishing its findings and advocating for food safety standards that would eventually lead to the Pure Food and Drug Act of 1906. She investigated indoor air quality, developing protocols to measure carbon dioxide levels in poorly ventilated tenements and schoolrooms, linking stagnant air directly to the spread of airborne diseases. She was, in essence, inventing the field of environmental science. Her work was rigorous, quantitative, and published in respected scientific journals. Her 1890 text, The Sanitary Chemistry of Water, became a foundational document for a generation of public health engineers. Her methods saved thousands from cholera, typhoid, and slow poisoning from their daily meals. Yet, as her scientific influence grew, so did the institution's effort to rebrand and diminish it. The revolutionary, cross-disciplinary science of oikology was systematically repackaged into something more palatable, more feminine, more domestic. The term home economics was born, and Ellen's comprehensive science of the human environment was shoehorned into its confines. It was a brilliant, insidious act of intellectual gerrymandering. The chemistry of nutrition became cooking. The engineering of sanitation became cleaning. The biology of disease transmission became household management. By framing her work this way, the male-dominated scientific establishment could both benefit from her discoveries and deny her a place in their ranks. She was never granted a full professorship. Her title remained Instructor in Sanitary Chemistry, a rank far below that of male colleagues with significantly less impactful resumes. The very system that relied on her data to train its engineers and chemists simultaneously denied her equal status. It celebrated her results while belittling the field she created to achieve them. The data was irrefutable, the impact on public health undeniable. So why was the architect of this revolution systematically walled off from the very institution she helped build? Whose legacy was being protected by diminishing hers? That wall of institutional convenience, however, was built on a foundation of scientific truth. And truth eventually finds a way to seep through the cracks. The echoes of that miscategorization, the deliberate rebranding of environmental science as women's work, reverberate even today. Yet, Ellen Swallow Richards's scientific legacy could not be permanently contained within the domestic sphere. Her methods were too powerful, her insights too fundamental. The very principles she pioneered, once dismissed as mere housekeeping on a grand scale, are now the bedrock of global environmental regulations and our entire public health infrastructure. Every time a city engineer opens a tap to test for contaminants, they are completing a process she designed. Every time a public health official maps an outbreak, they are using the epidemiologic logic she first applied to the wells of Massachusetts. Her ghost is in the machine of modern environmentalism. Look at the architecture of our survival. From the complex systems of modern water treatment plants with their stages of coagulation, sedimentation, filtration, and disinfection, to the stringent standards of food safety agencies that regulate everything from pesticides on produce to bacteria in meat, her influence is undeniable. The United States Environmental Protection Agency, founded in 1970, may not have her name on its charter, but its entire mission is a direct descendant of the Great Sanitary Survey she conducted a century earlier. The core idea that a government has a responsibility to use scientific data to monitor and protect the health of its citizens' environment is her idea. Foundational documents from the World Health Organization and UNESCO reports on sustainable water management implicitly trace their lineage back to her 19th century insights. They speak of integrated environmental management and the social determinants of health, echoing the holistic oenology she first conceptualized. Her work forms the silent, assumed foundation upon which entire fields were built. The academic and public effort to correct the historical record is now, thankfully, well underway. Historians of science like Robert Clark and biographers like Caroline Hunt have meticulously documented how her contributions were systematically sidelined. They have earnest the letters, the lab notes, and the institutional records that tell the story not just of a brilliant scientist, but of a system that actively worked to misclassify her genius. Universities are slowly re-evaluating her place in their histories, moving her from the footnotes of home economics to the main chapters of chemistry, public health, and environmental engineering. But the reclamation is far from complete. Her name is still not as recognizable as male contemporaries like Pasteur or Koch, even though her work on sanitation was just as vital to the dramatic increase in human lifespan over the past century. Her story is a stark reminder that history isn't just a record of what happened. It's a story told by the victors, and for centuries the victors in science were almost exclusively men. Every sip of clean tap water, every food safety label, every breath of air monitored for pollutants owes a debt to her relentless pursuit of a healthier world. Her struggle, her erasure, and her ultimate undeniable impact force us to ask a deeply unsettling question. How many other critical scientific truths, how many other world-changing breakthroughs have we collectively buried under the weight of prejudice and institutional convenience?